morning. My name is Adekunle-Odeleye. I'm a student in your class, and throughout the course of this class, we have learned about mathematics, how to do mathematics, and how to think like a mathematician. So this video project is a communication of all the things I have learned in the class and how I'm going to apply it to my major and how I'm going to apply it to real life. So the first one is definition. What is mathematics? Mathematics is the abstract science of numbers, quantity, and space. Mathematics may be studied in its own right or can be applied to other disciplines such as physics, engineering, and applied mathematics. And because I'm a history major, I'm not doing theoretical mathematics, so I'm not going to do that much of math classes, but the principles are very vital in other life. So, mathematics has a lot of misconceptions. So why should math matter and why should people care about math? One of the misconceptions we have is that it's boring, it's hard, and that we have computers and calculators now. So why do we need to learn math? Why do we need to learn the principles if we can just go on Google and check it? So the problem with that tendency is that just because you're not a mathematician, you're not a professional mathematician, that doesn't mean you're not going to need math. You need math for a leasing of your car, to know your insurance rate. There's a big difference between 3.5 and 3.2 over 30 years, 20 years. When you don't know basic fundamental math, it's easier for people to exploit you. Then another thing is that we have professional orators, we have novelists, but you still have to read, you still have to write. And knowing basic fundamental of math is an expectation in our society for good reasons, because we use math for a lot of things. Then a good example of what happens when you don't know math was that AW, a fast food chain, did 1.3, which is bigger than 1.4. But people thought they were being cheated on because they didn't understand basic fractions. And that's not, I didn't put that there to demean anybody, but it just shows how that math bleeds into our society, whether we want it or not. Okay, so doing math. So that's thinking like a mathematician. So one thing about being a mathematician is that when we have questions that a square and a rectangle, are they the same? You have to ask questions. You don't know everything, and you also have to check other mathematicians' work, because mathematics is a very collaborative environment. You can't just go on your own, and that's why you have to check resources. You have to check research, because you can't know everything, and it's good for you to build up on things. So when you get a question, you should try to get more information about it. So thinking like a mathematician. Mathematics is all around you. That's why we see frieze patterns. The frieze patterns in our paper walls, the frieze patterns in the Roman Empire. And so mathematics has even been shown in hard work in the golden ratio. We have seen the golden ratios in grades. We have seen the golden ratios in pictures. We have seen the golden ratio. We human beings are accustomed to see the golden ratio. That's why you see it in a lot of architectural work. And so as a mathematician, you should be very conscious of the environment and discovering math. So proving like a mathematician. Proving like a mathematician is you can't just having an idea is good, but okay. So this is the golden ratio. This is the golden ratio. This is the area, And so, like, as a novice, you don't see the golden ratio. You just know that it looks nice in your eyes. But science has shown that the golden ratio is very attractive to the human eyes. And this is a freeze pattern. And another thing that's found out is like there's a certain amount of duration, a certain amount of pictures that you put for animation for it to look animated and trick out of our eyes. So just because something is walking down the scene and you can't see it doesn't mean that math is not involved. So that's one thing this class has taught me, that a lot of things that we just see and we see the result has a lot of math beneath that. So proving like a mathematician, that's cool. This was one of the hardest ones for me, but what proving like a mathematician means is that you have to suppose the opposite. So I think there's a tendency as human beings for us to just form an opinion. So like, but math doesn't work like that. Like I like ice cream. I like vanilla ice cream. Like you're not gonna argue with me that strawberry is better. That doesn't matter. That's my opinion. But when it comes to math, you have to prove your opinions, because opinions are very cheap. Everybody has opinions on something. That doesn't make it true. I can have an opinion that the sky is green. That doesn't change the color of the sky. So as a mathematician, especially in the standardized field, you have to prove your work. It's one thing to have a theory, you have to become a theorem. So the first thing you do is you suppose the opposite. So there's nothing, so the specific, so you have a conjunction, then you have like a specific, like you have the rules for it. Then when you have those rules, you suppose the opposite. In case this doesn't work, does it work for everything? So you have the indirect and the direct. For the indirect or the deductive, you suppose the opposite. Like what in case it doesn't work? If you suppose the opposite and the opposite doesn't work, you have a proof in your hands. So the most important thing about a proof is that it has to be logical. So if I say 4 plus 4 is 8, you can't just like put odds and like put irrational numbers, make it make sense. It has to be involved, it has to be relevant to it, and it has to go through steps that work. Listen, and another thing is other people must be able to reproduce your steps and get the same result. And you can't have an outlier. Like it's not like English where you have shapes and you have different grammar rules and you have exceptions. For proofs, the proof has to follow the same standard for every single thing, and you can't have it the same. If it has an exception, it's not a proof, it's a theory. So creating like a mathematician. Creating like a mathematician is the work of art that people create, and that mathematicians are very vital for a lot of things we know. They help us with that. You need that for calculation for space. Like the space, like people going to moon, somebody had to calculate that. Someone had to make sure that this was okay. Someone had to calculate the space, the distance, and so many things. Because when we think of mathematics, we only think of the things, the theory mathematics, but those theory mathematics have applications. It has science applications for how we treat diseases. It has applications even in history, because there's some things you don't know, and you have to like deduct, you have to remove, you have to put it in a place, and that's one thing mathematics is very good at.